Hello friends, my name is Kushan doing MTech machine design in Chennai, MTech Audi. My project title is Analysis of Distortion Observed on Main Spindle for Lathe during Manufacturing Process. My internal guide is Dr. A. Arul Selvan sir, Associate Professor, Mechanical Department, MTech. External guide is K. Viraj Acharya sir, Deputy Engineer and Safety Officer in HMT Machine Tools. Abstract. During the finishing grading operation of the main spindle of the lathe machine, distortion is the dimensional accuracies are observed for the existing material and heat treatment processes, hence not able to maintain the required geometrical axis on the component. The heat treatment process are used in the case hardening of the existing material, that is EN353 is the causing distortion of dimensional and geometrical accuracies. The distortion rate of up to 30%. To work with this problem, it has been decided to change the heat treatment process as sub-zero treatment on the new component in addition to the existing process of hardening and tempering. As a result, changing the treatment as sub-zero treatment, the accuracies are increased to 0.05 mm from 0.030 mm. The main spindle of the lathe. In this spindle, number of spindle speed is forward 21. Range of spindles is 4.5. That means 450 rpm. Number of spindle speed reverse metric 120 short. Torque load is 1000 kg per meter. Accuracy of the spindle within 5 microns. In this spindle using in HMT machine tools for lathe 45. The lathe 45 is showing here. See this lathe 45. Next question is the problem of the main in this project. Distortion. Distortion can be defined as a irreversible and usually unpredictable dimensional change in component during processing from the heat treatment and from temperature variation and loading in service. The term dimensional change is used to denote changes in both size and shape. We will discuss about this by types. Types of distortion. Distortion in the general terms of involves all reversible dimensional change produced during heat treatment operation. This can be classified into two categories: size distortion and shape distortion or warpage. It is apparent here that some steels such as case hardening steels applicable increase in size of about 0.2% after hardening and tempering between 840 and 870 degrees Celsius and 180 to 200 degrees Celsius. Shape or warpage. This is sometimes called straightness or angularity changes. It is found particularly in non-symmetrical components during heat treatment. This is caused by the effect of more than one of these factors. After heat treatment, there are lot of problems in this heat treatment after heat treatment. The first one is straightening. When every possible case has been employed to minimize distortion, it may be still essential to straighten after heat treatment, which has already been discussed. Next one, dimensional stability. To achieve dimensional stability is the stability over long periods, which is visual requirement for the various unfaced bar. The amount of retained action in the heat treatment must be reduced because retained action slowly transforms the produce distortion and the material gets in at room temperature, heated or temperature. Dimensional changes caused by changes in metrological structure during heat treatment. The process of heat treatment is heating. When annealed steel is heated from the room temperature, thermal expansion occurred continuously up to where the contact is transformed from body centered cubic ferritic to face centered cubic astains. The next one is hardening. When astain is cooled quickly, maintenance forms, it intermediate cooling rates, bentonite forms, and slow cooling rates, periodic precision. In all this transformation sequence, the magnitude of expansion decreases with the decrease in carbon content in the astain. Next is Vickers harnesses. This machine is called Vickers harnesses in HMT machine tools they are using. Advantages of this machine: it can be used for extremely soft and hard materials. It is accurate and reliable. Next is the main column identification. Present manufacturing process of lathe means spindle at HMT MBX. Cut the material, forging, pre-turning, normalizing, machining, carbonizing and annealing to 1.2 1.5 mm case depth. Machining, hardening and tempering. Pre-grinding, internal grinding and external. Stabilizing and grinding. We are mentioned the red, the normalizing, carbonizing and annealing, hardening and tempering, stabilizing. They are in this area only the distortion probably occurred. The main one is hardening and tempering. The microstructure of main spindle not done on this year. Next is the material selection. The EN3 steel has been carbon content 0.17% and the most common from the steel. It provides material properties that are acceptable for many automobile applications such as main spindle of the lathe, heavy duty gear, shaft, pinion, etc. Heat treatment on EN3 series include the ductility, toughness, strength, hardness and relieve internal stress. Material components of EN353. The elements are carbon, magnesium, silicon, sulfur, phosphorus, chromium, nickel, molybdenum. They are recorded in this percentage, achieved in this percentage. Next one is turning operation. After material selection, the turning operation will be the operation of one of the most basic machining process. This is a pass rotated while single point cutting tool removed parallel to axis of rotation. Required diameter 177.8 mm. Because of the main spindle of the lathe is same size of the 177.8. Required length is 55. We are taking the two materials like this, same diameter and length for doing this project. The next one is forging. Forging is a manufacturing process involving the shaping of metal using localized compressive forces. The blows are delivered with a hammer. Next is the forging and normalizing microstructure. The shown in figure. Metal EM253, forged and normalized. Project sample. Hardness 190 BSM. Linear hardness number. Micro baseline grain size 57. Well discharged. F3 and Normalizing. Process cased by rolling and rolling. Forging or removed steels are heated above upper critical temperature. Soaked and cooled in air. The cooling air rate is faster than annealing, giving the smaller grain structure. Next one is heat treatment. Heat treatment first was the annealing. Heat treatment means carbonizing processes. Annealing. Make as metal as soft as possible. Steels are heated above upper critical temperature, soaked and cooled slowly, less than 0.83 carbon. Above 8.8 heated to critical temperature, soaked and cooled slowly. Next one is the process annealing. Low carbon steels may be hardened to cold working. They can be heated to around 100 degree below lower critical temperature, soaked and allowed to cool in air. Case carbonizing. Case carbonizing is the process used to harden low carbon steels that normally would not respond to quenching and tempering. Carbonizing introduces the carbon into the solid ferrous alloy by heating the metal in contact with the carbonized material to temperature above the transformation range and holding the temperature. After carboning, the steel will be have a high carbon case grading into the low carbon one. Of EN353 after carbonizing, they showing the red color of carbon contains 1.201%, increasing required one is 0.1 because after carbonizing we are note this point. Case carbonizing for job. Set temperature 930 degrees Celsius, soaking time 10 hours. Hardening. Hardening is a metallurgical and metalworking process used to increase the hardness of the metal. The hardness of the metal is directly proportional to the initial yield stress location of the stain. Hardening 840 degrees Celsius, soaking time 1 hour, quenching oil. Next, tempering. Tempering is the heat at 200 degrees Celsius as required. Soak for 2 hours and 25 mm of friction. The coolant still air. Surface hardness achieved 59 to 60 HRC. This one is a carbonized, annealed and hardened microstructure. Material EN353 same. Micro. Untempered metal inside with 15 to 20 Ra. Ra means retain strength. Hardness 59 to 60. The next one is carbonized, annealed, hardened and tempered microstructure. Retain strain and metal site shown here. Sub-zero treatment. This one is the main implement on this project. Sub-zero treatment literally means beneath zero. Beneath means below zero. As such, it is usually used for a negative numbers, especially with regards to temperature. Sub-zero treatment is usually conducted in the defined temperature and holding time with this temperature from 1 to 1.5 hours. This process required temperature of the least 8-85 degrees Celsius to begin. Sub-zero treatment is mostly frequently used to the as tools, measuring tools, and also a case carbonizing other machine components. Advantages of sub-zero treatment: improved stress relief, better dimensional stability, more uniform structural stability, improved wear resistance, useful techniques for sinking fitness. Carbonized, annealed, hardened, sub-zero treatment and tempered. After sub-zero treatment, we are taking the microstructure of this material for sample pieces. Material EN353, heat treatment case carbonized to 1.8 mm, hardened at 840 degrees Celsius, followed by sub-zero treatment. Micro fine tempered metasite with 2 to 33%. Hardness core 61 to 62, core 31 HRC. Next one, after that, we are measuring the Vickers hardness value, distance from surface in mm. 0.3, 0.6, 1.1, up to 2.5. Vickers without sub-zero treatment sample pieces. H3 0.5. The values are showing here 906, 970, Vickers hardness values are sub-zero treatment samples. They are showing the difference between both in the single slide. Next one is result and discussion. Grinding, internal diameter and outer diameter values graphs. Internal diameter of the outer 0.2 mm removal. Dimensional accuracy of the grinding 0.2 mm ID for sub-zero versus without sub-zero case hardened and tempered brushes. They are showing the boxes like without sub-zero, rectangle like sub-zero values. They are showing graphs how the shape will be changing or in this method. After 0.4 mm, showing the graph for dimensional accuracy of a grinding 0.6. See the difference with sub-zero or without sub-zero. They are showing this is next one is outer tire after 0.2 mm removal. In this also with sub-zero, without sub-zero are showing in this graph values and dimensional. This one is 0.3. This one is 0.4 mm after dimensional accuracy after grinding 0.1 mm OD, sub-zero versus without sub-zero. The graph will be clear while you seeing this. Next 0.5 mm. We take both four values for grinding internal and outer diameter. Next, scope of the work. It has been observed that the accuracy is required for the main spindle of the L45 machine while grinding is not achieved. To get the required accuracies as per drawing, new heat treatment process called sub-zero treatment has been added in additional term, the existing hardening and tempering. After doing a sub-zero treatment, compound has been grown with the depth of cut 0.01 mm in place of 0.03 mm earlier. Conclusion. The project main is conclusion. Carbon potential is high, 1.02 against 0.8 to 0.9 maximum. Hence, formation of retained acetylene has increased. Effect of ordinary temperature can be reduced to 820 degrees Celsius to reduce retained acetylene. From above result is when we observe that retained acetylene of 15 to 20% of affecting dimensional instability up to 30 to 50 microns of the components of without sub-zero treatment. From above result it has been observed that retained acetylene of 1 to 2% of improved dimensional stability up to 5 microns of further